So yesterday, my weather app swore we'd have clear skies, right? So I walked down to the grocery store and just got completely soaked in a torrential downpour.
Oh, no, that is the
Yeah,
worst.
totally drenched. But, a blown rain forecast is basically nothing compared to the weather report for the subject of today's deep dive. We are looking at WASP-121b.
Right, the famous ultra-hot Jupiter.
Exactly, a planet where it literally rains liquid rubies.
Okay.
So today we're unpacking the data you brought in to see exactly how the James Webb Space Telescope, or JWST, mapped out 11,000 mile-per-hour winds and gemstone precipitation light years away.
It really is a majestic testament to human innovation. I mean, just the gravitational mechanics alone are wild to think about.
Okay, so let's unpack this for everyone listening. WASP-121b orbits its star in just 30.5 hours, right?
Yeah, a 30.5-hour year, which is incredibly fast.
Which is insane. And it's so close to its star that stellar gravity actually warps it. Like, it stretches the planet into a football shape, sort of like a marshmallow roasting dangerously close to a campfire.
That is a perfect analogy, and because it's so close, it's tidally locked, meaning the exact same side always faces the star.
Right, so no day-night cycle like we're used to.
Exactly, and the temperature disparity is just staggering. The day side gets blasted with so much radiation that it's hot enough to literally vaporize metals.
Wow. Just vaporized iron floating around.
Yeah, exactly. But on the cooler night side, things cool down just enough for those vaporized metals like iron, magnesium, and the exact minerals that make up rubies and sapphires to actually condense.
And they fall as liquid metal rain.
You got it, liquid gemstone rain.
That is just mind-blowing. And, speaking of parsing really complex data to figure all this out, if you need help with AI training, automation, or software development, you should definitely check out EmberSilk.
Yeah, uncovering where AI agents can make the most impact for your business or personal life is huge right now.
Absolutely. Just head over to embersilk.com for all your AI needs. But okay, let's get back to the science here. How are we forecasting weather on a planet light years away? I mean, we don't have a space probe out there.
Right. Well, the Nature Astronomy study, we're looking at details how JWST measures starlight filtering right through the planet's atmosphere.
Okay, so it's looking at the light itself.
Yeah, the telescope essentially acts like a giant prism. As the star's light passes through the very edges of the atmosphere, different chemical elements absorb specific wavelengths. So it creates this chemical barcode.
And by reading that barcode, you can get the temperature.
Exactly. We can determine both the composition and the temperature of the gas, which lets us spot differences between the planet's dawn and dusk.
Wait, let me push back on that for a second. If the planet is tidally locked, meaning one side is always facing the sun, how does it even have a morning or an evening to measure?
Ah, that is the really brilliant part. It all comes down to transit geometry.
Meaning how it moves across the star from our point of view.
Precisely. As WASP-121b crosses in front of its star, its orbit dictates that it rotates just enough from our vantage point to expose its leading edge, which acts as the morning terminator, and its trailing edge.
Oh, I see. So the trailing edge is the evening terminator.
Yep. The evening side is the gas that just finished baking on the day side, and the morning side is the gas that just spent the whole orbit chilling on the dark night side.
That makes total sense. So what did the barcode actually show?
It revealed that the evening side is significantly hotter. Like hot enough to literally break apart water molecules entirely.
Wait, really? Just obliterate the water?
Literally tears it apart. But as that gas swings over to the night side and approaches the morning terminator, it cools enough for silicate clouds to form.
And here's where it gets really interesting, right? Because that massive temperature gradient between the morning and evening sides, that's the engine.
Exactly, is what drives those furious 11,000 mile per hour winds we talked about.
Just violently sweeping the heat from the day side over to the dark side. It's incredible.
We are literally watching extraterrestrial weather happen just by analyzing the shifting chemical silhouette of the planet as it transits.
So what does this all mean for us? I mean, if human technology has progressed enough to map the exact chemical makeup of a gemstone raining egg-shaped giant, imagine what's next.
Oh, the potential is just boundless.
Right. Imagine applying that exact same spectroscopic barcode to the leading and trailing edges of an Earth-like exoplanet. The breathtaking discoveries waiting for us out there are just amazing. We are truly living in an incredible era of exploration.
We absolutely are. It's an optimistic time for science.
Well, if you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.